Well, I've also already been introduced. So with that, I'd like to go into the introduction of what our customer does, going a step further in how they actually use the platform, what components are involved, how it technically works. Next, a short demonstration of what it looks like, and then a deep dive into the actual implementation. With the introduction, well, this looks like what it looks like at our customers. Racks with shelves with products on it. These are not the actual shelves, but the idea is the same. There are shelves, and these shelves are equipped with optical sensors that actually detect if something is on top of the sensor. And thereby, we can also see it in the picture here a bit, that here we have two rows of products. One is empty, one is full. They typically are at a slight angle, so as soon as someone picks up this tray or box, the back box slides forward, and always boxes are in front so that we always see or can grab boxes if needed. The solution is a rack of shelves, which are periodically being read, and thereby we actually know and we actually see what kind of information is available, or actually what products are available, yes or no. The products are, well, ordered automatically when someone picks a box from the shelves. They do distinguish between fast-moving products and slow-moving products. And based on whether a product is fast-moving, so customers use a lot of it, they have a shorter ordering interval than slow-moving products, where they know that if a box is empty, it could take 2-3 weeks before they need a third box to refill this hole for the other box. Thereby actually making sure that customers never run out of stock, basically, always have the products that they need when they need it. And that, well, it gives an extra little bit of service for their customers. A hype in the market nowadays is servitization. You sometimes see it in advertisements where printer companies sell you a printer where you don't have to order cartridges anymore. This is the same idea. You don't have to order the products anymore. They will be ordered automatically. Going a step further into the solution architecture, what it actually consists of is one or more shelving units with the shelves that are connected to each other. The shelving units are interlinked, and one or more of those shelving units are connected to a smart shelf controller. The smart shelves themselves are linked using Modbus, and all the sensors are read through the Modbus addresses by the smart shelf controller. That is all handled inside the controller itself. The hardware and the controller are not delivered by Software AG. We obviously only do software, as our name also indicates. But we've worked tightly, strongly together with this hardware supplier, discussed about the protocol to use. The smart shelf controllers actually use 3G to communicate, and some older models only have a 2G SIM card, but they communicate with our Cumulocity IoT platform. Since it's 2G, since it's a proprietary protocol, we need to make sure that the data being sent from the smart shelf controller is being able to be interpreted by the Cumulocity IoT platform. And that's where the microservice comes in. The microservice takes the proprietary format coming in. In this case, it's a certain message coming over HTTPS that needs to be decoded and translated in the generic domain model which exists in Cumulocity IoT. There we will translate the messages into measurements or events. Cumulocity IoT not only just receives messages and events, measurements and events, it is also able to manage devices. And to manage a device, you want to be able to actually send commands back. So you want to actually, in case you want to change settings, send a message back to the smart shelf controller. Since it's over 2G, we typically don't know where the controllers are, don't have IP addresses. They can change very rapidly over time as soon as the connection is restored, etc. So it's quite difficult to initiate something from Cumulocity to the smart shelf controller. Now, how does that work so that we can still do our device management? Each time the smart shelf controller will actually send a message to Cumulocity IoT. The measurement will be recorded. And while the measurement is being recorded, we also check in the microservice that we've developed whether or not there is an outstanding operation that we need to send back to the controller for it to do something like changing configuration, updating a firmware, sending log files. And if there is an outstanding operation, we actually send back a message in the response of the HTTP message that was just sent with all the measurements. We have an operation for you, and that operation is of the type retrieve log files or update settings or download firmware. And as soon as the smart shelf controller in the response sees that there's an outstanding action and what type of action it is, it will invoke another endpoint on the microservice to retrieve the settings, upload the log files, or download the firmware. That is what the microservice takes care of. The microservice, well, receives measurements, and the measurements are just signals. Position 1, 2, 3, 4, 5 are full, full, empty, full, full. So the only thing that the shelving units know is that there's a position that is occupied or vacant. It does not know anything about any products at all. So how do we actually make sure that the right products are ordered? For that, the customer representatives of our customer, in this case the vendor domain, they actually keep track of the configuration of these shelving units. So together with their customer, the vendor in this case will decide these products are located in these shelves at these positions. Thereby, we know that if we take a look at, for instance, this position on this shelf, we know this is a certain product and it has a certain product code. The position here in the middle is another product with a different product code. The one here in the bottom, yet another product code. They store all of that information in their SAP system. And what we then do is we make sure that this smart shelf configuration is uploaded to our Cumulocity IoT platform so that we know what product is located at what shelf and position in the shelving unit. Thereby, we can, in our Cumulocity IoT platform, make a match between a position that actually went from full to empty, relate that to a product as how the vendor knows that. When we know the position, when we know it went from full to empty, and we know that because we keep track of the previous measurement and the current measurement, uh, by differentiating, okay, is something in the previous measurement full? Is it in the current measurement empty? We know a box has been picked up and has been used or is empty. Thereby, we create an event and we attach it to, well, the smart shelf configuration, which article number is located at that position. We then send that information back into the vendor domain where the vendor knows product X has been emptied, so we need to create a new shipment for this customer where the next delivery he will need this product as well. And over time, between the shipping moments, these events stack up, and at a certain moment in time, they know, okay, now it's close of the ordering moment. These are the order lines. This is what we need to ship to the customer. This information of all the products that are emptied, that are available, etc., will then also be put into a dashboard that the customer, in this case, decided to place on-premise. In most cases, Cumulocity IoT would also be able to display the dashboards with information about products being used, products that need to be replenished, etc. But also combine it with historical information. What were the previous orders that were delivered? What is the general trend, etc. That's what they decided to put in their own portal, because they use that portal for manual ordering, well, dashboarding and visibility for their clients, questions. They also use it for invoicing. So they had one place to give visibility. And Cumulocity IoT is actually the motor of the project, feeding the information to the order process and the dashboarding process. Thereby, I think I've given a good introduction of what the technology works like. And that leaves us to demo time in my case. So here I would actually like to take a look at what does Cumulocity IoT look like, how do we do device management, and then the next step would be taking a look at the code. Quickly take the right window. Yep. So here we have our browser with Cumulocity IoT. If you're not familiar with it, this is our device management application in Cumulocity IoT. We have multiple capabilities. Administration is where we can configure user roles, settings, those kind of things. Also see log files of the microservice. The cockpit is something where we create dashboards for end users so they can easily see what's going in with their business process, how are devices reacting, but also where is my device located, especially if we have track and trace on the device. And streaming analytics is what we can use to analyze data in real time, apply rules on them, and those rules can be machine learning rules, but also very basic rules. If a threshold has been exceeded, do this or do that. At this moment, I would like to take a look at the device management. What is it? Well, first of all, it gives us information about the device. In this case, also about the status of the device. Luckily, this device is online, which meant it had sent its communication within the required interval of 1440 minutes in this case. We can very easily change this interval into 60 minutes, for instance, and that would then change the interval in which we check if a message has come in, whether or not the device is live. In this case, messages have been sent, so we have had a measurement, and that means we do know well, which positions are full and which positions are empty. We also have device data about information about the device. It will tell us that this is a so-called optical bin. That's what our client calls these smart shelves. And it's an optical bin of the type W315LX. We do have a difference here because they do have two types of controllers that they deliver, like you could see in the architecture slide. One of the controllers is a 2G version of it. The other type is a 3G version of it. Does that matter? Not so much, apart from the firmware. We can do firmware upgrades, and for the firmware, it does matter which device you have. We'll take a quick look at that at a later moment. Other information it collects is information about the firmware, which version is currently installed on the device, and what kind of type is it. But it also collects information about serial numbers so that we actually know, excuse me, it's this device located at that customer. And that's why they also record the location of the device. So they also know this device is attached to their customer with that number. This is basic information. So it shows us some static information. It shows us location information. Where is it located? We can assign it to groups. In this case, we assigned it to experience room. So this is a demo environment where they have a rack positioned. But we can also assign it to different groups. For instance, we could assign it to multiple groups to also indicate it's either it's both a smart shelf related to customer X, but we'll also assign it to a group for the 2G or the 3G devices. And thereby we can always mix and match what we would like to see. Now, what kind of device management can we actually do with this platform? Like I mentioned, there's something that we can do like reading log files. We can send log file requests by clicking log file request, select what type of log file we would like to retrieve, and well, give it, let's say we'll want the status log, request a log, and this will actually create a command. Like mentioned before, we need to wait for the controller to contact Cumulocity IoT. As soon as it delivers its messages, it will actually see that there's a log file request pending, and it will then, based on that pending operation, send us the log file. To well, accompany this process, to facilitate this, we have statuses for these commands. In this case, we can see the command is pending. We're waiting for the controller to pick up this command and then execute it. We can also go to the control tab and actually see what commands have been executed in the past. And we can see we've restarted the device, we've updated configuration, and we have a pending operation for the log file request. The configuration is also a good one. Here we can define all kinds of settings that we would like to update, that we can then send to the controller so that we can change the interval in which it's sending its measurements or something else. With firmware, we can select replace firmware. In this case, we have two versions of the firmware, a version 5.10. So this one is running on an older version of the controller firmware. And we could simply select install the new firmware. And that will again create an operation that will send this command to the controller to update itself. And next to that, well, like I mentioned, the measurements are being sent in, and based on the measurements coming in, we determine whether or not a bin, and that's a location, has been changed to empty. Later we can see in the code where we actually do this. And thereby we, well, have a very quick, rough overview of what we can do with the device management of this optical bin, this smart shelf. Receiving measurements and also, well, managing the device by reconfiguring it, updating it. Hereby, I would like to take a moment to step to the code and quickly look at what is it that we've created. Since it's a microservice, I do have to mention, in this case, I've used Java to create the microservice. But since it's a microservice, it in the end becomes a container, which means that you can use your favorite language to build the microservice to interact with Cumulocity. So it does mean that you could use Go if you like that, or JavaScript, or yeah, whatever favorite language that you have to build microservices in. Since I'm pretty well educated in Java, it was easy for me to use Java and Spring Boot to create it and give you a quick insight of what it is that we've created. If you're familiar with Spring Boot, you might know that you have a typical project descriptor, which we call pom.xml. In that file, we define the name of the project. In this case, it's the microservice. We give it a group, and then we define a couple of, well, properties and dependencies. The properties here, we define versions of dependencies that we would like to use. For instance, the Cumulocity version 10.7, which means I actually do have to update it to the latest and greatest. And then the dependencies, where we define that we want to use the device capability model of Cumulocity and the microservice auto configuration. By importing these two dependencies, we automatically get all the capabilities for the microservice. So it will include everything to make a REST interface. It will include everything to communicate with Cumulocity. And thereby it is very easy to get started. As the main entry point of the code, we actually have the main class, which is app.java. This is a typical Spring Boot application, and for the ones that don't know Spring Boot, might be a bit well, puzzling. We don't do anything here. The only thing we do is, with this class itself, the application itself, we run this application. But what magic does happen here? There's a couple of annotations, the microservice application and the REST controller. These annotations actually tell Spring Boot that A, it's microservice, so it will use some of the resource configurations to load settings, to communicate with Cumulocity. And the REST controller means this is a REST application, so instantiate an internal web server with the hook so that we can use REST to interact with this microservice. Then the magic actually happens in the basically auto loading of what we call surfaces. And here we have an optical bin surface. And this is actually where all the magic happens. This class is annotated by the controller annotation. And this controller annotation ensures that in Spring Boot, this will be loaded as a REST controller. So this will automatically be loaded by the app. It will introspect where do I have surfaces, or in this case, classes that are annotated with controller, register those as a REST surface so that we can use those. This is actually not important. These and the set action is also not important, but the post mapping, this is the main method that we actually use. The optical bin controller, so the smart shelf controller, always sends information using post to an endpoint, an HTTPS endpoint. And we actually catch this by creating a post message on the path cabinet. So this will translate in a web service endpoint cabinet on which we listen for a post message. And all the magic to process that post message is mainly done by all kinds of annotations, like the request body being available in our input, the output being a response string that we can very simply return. And we'll walk through by actually running through all the parameters that come in to identify, well, the MAC address. The MAC address is the serial number of our device. We'll retrieve the MAC address. We'll retrieve an action if it's provided. And that's also done here in the get mapping. And the get mapping is where actually all the, or most of the actions happen. So for instance, retrieving firmwares, retrieving the firmware hash, and retrieving the configuration, those actions are done through a get operation. They call the cabinet endpoint with a get HTTP action. And they will then, based on these settings, request Cumulocity to return the configuration or return the firmware itself. And we then return that firmware into the surface. The post will actually read all of the settings that we've created. First, based on the MAC address, it will try to retrieve the device from Cumulocity, which we do using a wrapper service over here. And if the device cannot be found in Cumulocity, we'll actually create the device. So that means that as soon as a new device registers itself, it will actually appear in Cumulocity. It will be created by this microservice and will provide it the serial number, the model, and the version of the device. In case that the device already exists, we'll check if we need to update the device. For instance, if the version of the firmware is updated, and you can see here in this line, the version is actually retrieved from a user agent header, and that user agent header contains the version of the firmware that is being used. And then we could update the device that, okay, it has been switched from version 5.10 to 6.4. And then we have a little bit of inside validation versions for keys, which I won't bother you with. And then we'll actually process the actual, well, bin states. That's what we call them. So we will actually jump in, and that's over here. And we'll walk through all of the locations, and that is what we see here. An iterator that will walk through all the positions that are provided, and we will check if the bin state has been updated, yes or no. We'll update some information, and we'll create a measurement. We will also create an event in case the bin state has been switched uh, from full to empty. And in that case, we will create an event so that we know that ordering can be created. Looking at the time, I guess I'll suggest to stop here in details. Anybody who has more questions about the code, who wants to know more, could ask the questions in the question and answers. One thing else I'd like to see show is, well, we have the application properties which we can use. Those, for instance, together with configuration, are the configuration settings that we actually need for creating the microservice. These two configuration settings actually end up in the service, the Spring Boot being able to recognize this is a microservice. I do have a health endpoint, so microservice platforms like Kubernetes can actually query this endpoint to see how healthy is this microservice, how much memory is used, how much CPU is it using, is it still functioning, and thereby actually having it ready and available for the microservice to also be able to restart in case it's not healthy. By that, I think we'll conclude. If there's any questions, please feel free to ask them.